Welcome to aminacademy.com. In electrical engineering, let us discuss about capacitance between two parallel wires. In practical importance of this case, that is capacitance between parallel wires, is an overhead lines as shown in figure. Look at here. This is an overhead line of two parallel wires going long distances. The two wire system is shown in figure, either AC or DC. In AC system, if the length of the transmission is too long and voltage is too high, the charging current drawn by the line due to capacitance between two wires has a considerable value and it affects the performance of the line. Let the radius of each wire, let it is R meter, and the two wires be separated by the distance of d meters. Let a charge q coulombs be given to the point A. The charge of B will be minus q coulombs. Look at here, the given things are d equal to distance between two wires in meters, and R radius of each wire, and Q is charge in coulomb. Q is charge in coulombs per meter. Charge coulomb per meter length of the wire. Now let us consider the electric intensity at any point P between A and B. Electric intensity first, we will consider the electric intensity at C, which is between A and B as shown in figure. Electric intensity at C is due to positive charge Q coulombs per meter on A is E1. Electric intensity. Electric intensity is E1 is Q over 2 pi epsilon 0 epsilon R X. That is at a point P, at a point O we are considering. From due to Q coulombs on wire A, at electric intensity at point O is X distance is Q over 2 pi epsilon 0 epsilon R X towards B equals. Electric intensity at point C. At point C, due to the charge is minus Q coulombs. Here, first is electric charge at point A is E1 is Q over this 2 pi epsilon 0 epsilon R X. It's not at C, here at A. Then due to this electric intensity, the electric intensity at C due to the charge of this one is minus Q coulombs per meter in B is here. Let's look at here. E2, this is total distance is d meters. So this is the x meter, then d minus x is from CO to B. Therefore, electric intensity at C due to charge of minus Q coulomb meter on B is E2 equal to Q over 2 pi epsilon 0 epsilon R d minus x, the distance from B to that point C towards B. Now, therefore, the total electric intensity at point C is adding of these two things, because it's a positive coulomb, it's a negative coulomb, so attract each other. So here, this addition of two electric charges, that is E equal Q over 2 pi epsilon 0 epsilon R 1 over x plus 1 over d minus x towards B. Hence, the potential difference between the two wires is here what we called integral R to d minus R. Therefore, E into dx, electrical intensity with respect to x, that is integral E dx equal, that take out the constant terms, that is Q over 2 pi epsilon 0 epsilon R, integral of R to d minus R, integrating 1 over x plus 1 over t minus x. Look at here, this constant term as it is taken out, a q over 2 pi epsilon 0 epsilon r. 1 over x integral is ln x plus 1 over d minus x is here negative and positive. So instead of this one here negative you are considering because this charge is opposite. That is 1 over. Now integral of 1 over d minus x is 1 over d minus x and x integral is minus 1, that gives minus here. So q over 2 pi epsilon 0 epsilon r ln x minus ln of d minus x. So substituting the value of limit values d minus r over r. So here therefore v. So integral e dx is v is q over q over pi epsilon 0 epsilon r ln, because ln x minus ln d minus x, that is substituting this limits d minus r to r gives finally v equal q over pi epsilon 0 epsilon r ln d minus r over r. Then from this we can get it c equal to q over v. Capacitance is q over v. From rearrangement this c equal pi epsilon 0 epsilon r over ln d minus r over r. So we are converting this ln natural log to base 10 log. We give 2.3 log d minus r over r. This is equation 1. Therefore, the capacitance for the length 1 meter is given by, this is 1 meter, given by C equal pi epsilon 0 epsilon r into L. Because it's so for 1 meter, for length, full length is pi epsilon 0 epsilon r L over 2.3 log d minus r over r. This is equation 2. Therefore, the capacitance per kilometer is given by, this is full length length, then capacitance per kilometer is given by, now we are using this 1 kilometer values, that is 1000 meter and 2.3 divided by 2.3, total it gives after calculating this simplification we get C equal 0.0121 epsilon r plus epsilon 0, we are using 8.85 into 10 raised to minus 12 as well as this 2.3, that length values, everything we are using to get 0.0121 epsilon r log d over r microfarad per kilometer. This is the simplest form of that capacitance between two parallel wires per kilometer length. We have done. Please subscribe our YouTube channel.